Wonderful students, we're back. Okay, I'm going to finish up these properties of exponents with you guys. There's 3 left. The first one is when we have an exponent raised to a power, so power of a power. So if you have a to the m raised to the n power, we're going to multiply those exponents. So for example, if I have x squared to the 4th power, we're going to multiply that 2 in the 4th. So this equals x to the 8th. One way to think about that is it's x squared times itself 4 times. So it's x squared times x squared times x squared times x squared. And in the previous video, we learned that when we're multiplying bases that are the same, we add their exponents. So 2 plus 2 plus 2 plus 2 gets you right back to that x to the 8th power. All right, power of a product. If you have a scenario, this is a little bit different, but quite similar to the one that we just did. A times b to the m power. That m is going to apply to the exponent by way of multiplication for each of those variables, or sometimes you have a coefficient inside. So if I have like x squared y to the 3rd, and that entire thing is raised to the 3rd power, I'm going to distribute that to each of the exponents inside. That's how I like to think about it. So this would be x to the 3 times 2 is 6, times y to the 3 times 3 gives me 9. Now be really careful with this. Here's another example. Coefficients always get forgotten. So if we have like 2 q to the 3rd, r to the 2nd, and that's being raised to the 4th power. Remember, this 2, even though we don't write it, really has an exponent of 1. So I need to distribute to all 3 of those. So that'll give me 2 to the 4th times q to the 3 times 4 is 12. R to the 2 times 4 is 8. And then, of course, we can come back and say, oh, 2 to the 4th, that's 2, 4, 8. That's 16. So it's really 16 q to the 12th, r to the 8th. Yeah, so just remember, even on a variable, if you don't have an exponent, the exponent is 1. You still need to apply that. Same thing if you have division inside. So this is really similar to the one that we just did. The only thing is it's division. So this m, this exponent out here, applies to the numerator and the denominator. So much like the product on the second one, the quotient on the third one is going to behave the same way. So if I have something like x squared over y to the 3rd, and this whole thing was raised to the 3rd power, this 3 is going to multiply by both exponents. So that would be x to the 6th over y to the 9th. Similar to what we talked about just above, let's say I had 2k to the 3rd over 3r, and that whole thing was raised to the 5th power. Remember, 2 has an exponent of 1, 3 has an exponent of 1, r has an exponent of 1. So it's going to be 2 to the 5th, k to the 3 times 5 is 15, 3 to the 5th, r to the, I think that was the first down here, right? So that would be r to the 5th. Okay, I don't know if I can simplify these in my head. 2 to the 5th, I think that's 32. Three to the 5th, I would not expect you to do in your head, but let's see. 3, 9, 27, 81. I think that's 243. Okay, so let me do a few examples with you. I think I have 3 circled ones. Power of a power, d to the 5th to the negative 2nd. Remember, I can multiply those together, so that is d to the 5 times negative 2, which is d to the negative 10th which from the previous video, we know that's 1 over d to the 10th power. Always want positive exponents. 19, negative 2d to the 10th, that entire thing raised to the negative 2nd. Okay. So remember, this negative 2 has an exponent of 1 right now. There's a couple ways we can do this. I think I'm just going to go ahead and distribute the negative 2 rather than try to turn it positive. But I'm going to have negative 2 to the negative 2nd times d to the negative 20th. Now we want to have positive exponents, so this is all over 1. If I take the reciprocal, I guess technically we should say this term's over 1, that term's over 1, right? So I would have 1 over negative 2 squared times 1 over d to the 20th, which will equal 1 over negative 2 squared is 4, 4d to the 20th power. Okay, last one. Okay, a couple things we can do. I think I'm actually going to start inside here. Let's actually square that negative 2x. So negative 2 to the second times x to the second. Negative 2 to the second is positive 4. X to the second is just x to the second over 3xy squared, and that whole thing to the third. Now notice I have an x squared on the top, x on the bottom. You can reduce that, and maybe I'll do that next. So this becomes x to the first. This x is gone. Now let's make sure every term has an exponent, because I need to distribute this 3 to those exponents. That's getting really messy. I don't think that's the best way to do it, but so that'll be 4 to the third. It was x to the second, but I canceled one, so it's x to the first, then to the third power. So that's x to the third over 3 to the third, y to the 6th, right? Because it's y squared. 3 times 2 gets me 6. So 4 to the third is 64. 3 to the third, 27. So there we go. Thanks, guys.